soundcheck. Hallo. We hebben dit een keer bij een petrochemisch bedrijf gehad. Gingen ze dan een presentatie doen. En de hele dag door de dag gewoon te werken. Waren ze dan, Dankjewel. Okay. All right. Hello, everybody. Welcome to this talk that we'll be hosting here, Robben together with Daniel, regarding Shapeshifter. Is the sound okay? Also in the back of the room, clearly hear us. All right. Robben, you can come in now, I guess.
Hello.
Test.
Okay. You were first with the test.
Yeah. So you're next.
Yeah, but this is still the sound check.
I hope so. This is the audience.
Ja. Kan hoor, kan. We kunnen, daar is ook een klok, hè, dus we kunnen daar even de tijd in de gaten houden.
Ah, cool.
We
hadden tot 5 over of zo hadden we.
Ja.
Ik heb hem gezien. Ja, goed. 11:15.
Ja, dus we moeten dan even, ja, dat redden we denk ik makkelijk. 15.
Zeker.
En als we dan kijken of we om 10 kunnen stoppen, of om 5 over. En dan hebben we nog tijd voor wat vragen.
Ja, vind ik een goeie.
Als die er zijn. Dan,
heb je nog een goede mop of zo? Stel dat
voor
we...
nu?
Ja, nee, gewoon straks.
Tijd over...
Dat is tijd over gaan. Check. Jij mag checken.
Test. Sound, is the sound okay? Yeah. Very good.
Een fotootje, kom even erbij staan. Als jij daar gaat staan.
Ah, ja.
Oh ja, now we need to do it together, right? Can you also talk?
Yeah, I can talk as well.
All right. Here's some check. 1, 2.
Talk in each other's microphones.
Yeah.
Yeah.
Cool.
Sounds good.
Lovely.
Jullie zien op jezelf op het scherm niet?
Nee.
Nee, helaas niet. Weet je.
We see our presentation twice.
Ja.
And what is this? An screensaver.
Ja.
Screensaver here.
Ja. Ben je product manager? Oké. Dus ik weet niet.
Wat dacht je dan?
Ik weet niet.
Aanklooier. Nee.
Oh. Zo weinig mensen denken. Ja.
Even wachten tot degene die net naar buiten rende terug is.
Ja.
Wordt ook opgenomen trouwens, dus het wordt ook live streamed.
Gaaf. Ja, dan moeten we wel echt een hele goede afsluiter hebben.
Daar zit het grote publiek natuurlijk.
Ja, dat is het. Daar zitten miljoenen.
Right, I think we'll start slowly, and hopefully the sound of our voices will attract the people still sipping their coffee to also join us. Otherwise, there's like not so much time left for our presentation. So we'll just start. Thank you for attending our presentation about Shapeshifter. Let's start by introducing ourselves. My name is Robben Riksen. I'm product manager at GOPACS, the grid operator platform for congestion management in the Netherlands, where all Dutch grid operators collaborate together to coordinate their congestion management efforts. And speaking with me is Daniel.
Yeah, I'm a Python developer for Enexis. I was involved since 2017 building one of the first versions of a grid management system, in which we started with something that was before Shapeshifter. So welcome everybody. Thanks for joining.
Thank you. We'll start with this slide. It's a story you heard also this morning and yesterday, but I'll reiterate it because it stresses the importance and the urgency of what we are doing. So looking at the trends in the energy transition, we see three things that impact the electricity grid. We see a shift from centralized to decentralized energy production, where it's not from production facilities, but lower in the electricity grid. We see an increasing simultaneity in the electricity production and consumption, because if the sun comes up, all solar panels in the street, they start producing at the same level at the same moments in time. And also when EV users, for example, come home after their day of work, they plug in their electric vehicle, and if we don't do it right, all vehicles start charging at exactly the same time, increasing the duck curve. I learned that yesterday, that it's called like that in the United States, with the evening and morning peaks, and increasing the peak load on the electricity grid even more. And we see the increasing electrification. I mentioned EVs already, changing internal combustion engines to electric vehicles, and also in the source of heating, where we replace natural gas with heat pumps. And those impact the electricity grid that was designed for the old energy system, and it is not designed for the energy system of the future, which is already here for a lot of, for most part. And so that drives the electricity grid to its limits. And we see that in the Netherlands. I'm most familiar with the case of the Netherlands, where we have many congestion problems. So this is the map of the Netherlands, the capacity map that is published by the Dutch grid operators on their websites. And to be clear, orange and red, that's not good. So where it is orange or it's red, there are customers that want capacity on their grid connection, or want a new grid connection that the grid operator is not able to facilitate. So those people have to wait. They're on a waiting list. And therefore, this situation is putting a halt on the economic development in the Netherlands, but also on the energy transition, shifting to more sustainable ways of driving our cars, for example, and producing our electricity more sustainably. So the sense of urgency is obvious, I think. So what do we need to do? What can grid operators do? Of course, they try to expand the grid and do it as fast as possible, but this is a slow process with a lot of regulations and local impact. So in the meantime and in the future, we need also to look as grid operators, how can we utilize the electricity grid that we have currently to more extent. And one of the ways that we think we can do that is using flexibility in the electricity grid. So, for example, if you look at this picture, this is, let's say, the old situation where you have a grid capacity and a contracted capacity. So the grid operators contract grid connections with a certain capacity that is slightly above the grid capacity, but not that much, and there's a large margin of safety between what the consumers or producers use of the grid capacity and what the grid can handle. What we hope to do with flexibility is give grid operators the comfort of the confidence that they can procure the flexibility they need to give out more, contract more capacity to connections they need, driving the expected use closer to the actual grid capacity, because if there's an overload or a forecasted excess of demand, then there is flexibility in the market that the grid operators can use to mitigate congestion problems, and even contract capacity up to levels which they know that their expected use at some points in time, daily or weekly or monthly, will exceed the available grid capacity, because they can use the flexibility in the consumption or production and have the means to flexibly, I heard the term peak shaving yesterday, to remove the excess demand for capacity and transfer it to a different time of day. So what capabilities does a grid operator need to have to be able to do this? Because it's a different way of operating than it used to be for grid operators, where it was just you put your cables in the ground and then after a while you come back and maybe do some maintenance. We need capabilities in creating insights, so you have to know what the capacity of your grid is, you have to know what the forecasted demand is, and you have to have a real-time insight in what's happening in your grid. You need to be able to identify problems, forecast at what times the overload or the expected congestion problems will occur. You have to have a portfolio of solutions, but which you can choose to have the confidence that when you need it, the flexibility is there. So no situations with generators that are not available when you need it, as we heard this morning. You need to be able to activate the solution, so you have to be able to communicate with the marketplace or the customers offering you flex. And lastly, you have to evaluate and settle. So you have to pay the customers that are providing flex to you, the flex providers, and penalize them if they are not providing the flexibility you procured. And this is where, in this chain, the flexibility value chain, this is where Shapeshifter comes in. Shapeshifter is coming from the Universal Smart Energy Framework, short USEF. That is a broader framework. In 2014 it was founded with a lot of companies, utility companies, energy producers and technical companies that were describing the market model and describing the smart energy ecosystem with the roles that we need for the energy system of the future. And after that, it has been implemented by, for example, Dutch TSOs in several pilot locations. And in 2020, it was updated, and specifically one part of it was specified further in the UFTP protocol, USEF Flex Trading Protocol, which describes in detail the market interactions and the messages between aggregators and DSOs, grid operators, on how to manage this flex market. In 2021, UFTP became part of the Linux Foundation Energy Flexibility Suite as Shapeshifter, and that is what we are presenting here today for you. So we're relatively new in the Linux Foundation Energy. A lot of echoes on my mic. And we want to introduce Shapeshifter to you and also show you one of the use cases. So what is Shapeshifter? What does it describe? For that, we look at the flexibility value chain as it was described by the USEF framework. And you see here we have in the electricity grid consumers or prosumers with a lot of equipment that that potentially can provide flexibility to grid operators. We have the grid operators that have congestion problems or have congestion problems caused that are looking for this flexibility. And in the center of this framework, we have the aggregator role, which is an important role, a market role, as we see it, where we try to create a market and stimulate market parties to use to drive the innovation and to have a financial incentive for parties that go out to prosumers and tap into the flexibility they have available but might not be using, or even install, for example, battery systems that can provide flex to grid operators. But there has to be a marketplace where they can make money from the investments. And that is one of the problems we are facing, one of the challenges we are facing now. It's sort of a chicken and egg problem where we have grid operators that have shown in pilot locations that this works, that the flexibility market works, and that it can help relieve congestion problems. But to apply it on a national scale, as you saw in the Netherlands, might be necessary. You have to have the confidence that the flexibility market is there when you need it. And on the other side, you have the aggregators that need to make investments to install flexibility or need to make investments to participate in this flexibility market, that want to have some sort of confidence that they will make a return on their investments and that the grid operators will eventually make a step in applying this market in a larger scale. And that is what I think is the importance also of open source and open sourcing this Shapeshifter protocol to lower the bar of entry for aggregators. The more people that can easily access this market, the better we can use the innovative force that is in a market, in a free market, to make this flexibility available and also drive grid operators to use it. So we see 5 phases in the UFTP protocol, or the Shapeshifter. We have a contract phase in which that is optional, where grid operators can contract capacity with aggregators. So they have a bit more certainty. They can discuss the fees, for example. Then we go into an iterative plan and validate phase where parties optimize their portfolio. Grid operators do grid safety analysis to see whether they expect congestion problems, and they can send flex requests requesting flexibility from the market, from the aggregators that are known to them. The aggregators can send flex offers offering the flexibility at a contracted price or at a market price. And after that, we go to the operating phase where, of course, the grid operator, nearing the time of delivery, monitors its electricity grid and sees whether it needs to request or order more flexibility. And lastly, the settle phase, which I mentioned earlier. The Shapeshifter protocol can be used in several ways. So we have it in a bilateral trade way where there is a direct communication between DSO and aggregator role. So there's a bilateral way, or in an exchange or through a coordination platform way. And both of these operation modes we see in practice. For example, we have the Fusion project. This is a full implementation of the Shapeshifter protocol in Scotland by Scottish Energy. And the most recent implementation of the protocol is at GOPACS, where I'm working, where we use it. It's a grid capacity management coordination platform, and we use it to activate contracted capacity for flexibility and for congestion management. And then I hand it over to Daniel, who's working at Enexis, one of the grid operators in the Netherlands that is using GOPACS, and therefore Shapeshifter.
Yeah, thanks. Yeah, welcome again. Daniel, Python developer for the grid management system for Enexis. The history that we have with the protocol is that in 2017, so I'm going to look at the past, the present, and the future. So the past is in 2017, we started with the UFTP protocol, and that was as part of a project that we did, an innovative project for the European Commission for one of the Horizon 2020 projects, Interflex. With that, we performed load forecasting with the system. We then determined how much flexibility we needed. We had communication with an aggregator. They were a charge pole operator, so they determined, okay, how many electric vehicles are there, how many charge poles are there, and we communicated with them using UFTP at that point, UFTP version 1.01, so that's the old version, to provide them with an insight into, okay, we have congestion at a certain point in time. Here is the timeline when there's still availability. If you can please move that congested power to the other parts where there's no congestion, then everybody is happy, we can perform flexibility, and that's okay. From that, we evaluated and said, okay, this is great, this works, this was innovation, let's do an experiment with it, because you need to try it out if it really works in your own company. So We decided to create an experiment, and the experiment was that we were going to experiment to see if we can use flexibility to prevent already getting bigger cables in the ground. It bought us time, see if that is possible. Then we can schedule that later, because that's a long-term solution possibly, and see if flexibility can fill the gap. So that's the experiment that we did. After that, from about 2020, we were building our grid management system, and the grid management system is a modular system in which we can choose a solution for instance, day ahead, intraday today, intraday tomorrow, and we see that UFTP, as it was successful for us, and we have experience with it, was an effective protocol to also use in the future for day ahead. So day ahead, we're going to use Shapeshifter. And if I go to where we are now, that is that we're finalizing the implementation for Shapeshifter, with which we communicate to the GOPACS platform. So GOPACS has an implementation where users can use a UI, that they do not need a full implementation, but we use Shapeshifter between those systems to make sure that we can have capacity limit contracts. And for the future, we see that open source is important. Our whole journey was that we wanted to use Python because it's easily available in open source. We wanted to build something that is modular, scalable, and something that you don't have a vendor lock-in. So for the future, we're looking into doing more with open source. We're exploring that. Okay, next slide. Then our takeaways from this whole stuff is the first thing was innovation. You just start building. You have the specification. And the specification is a document of like 60, 70 pages, and you start it up and you start typing. So it's really iterative, and you're trying and interpreting. And at that point, you have it, okay, this works. It doesn't work, it breaks. All right, now it works again. And then you have something that you can test. You can verify the functionality and see if it brings value. But from there to where we are now using it. We have to comply to the law. We have the law of congestion management in the Netherlands. And that's really hard. It needs to be a production system. So the first thing that we had, like it works on my machine, see, we can communicate. That's different from, all right, this needs to be a production grade system. If we do this wrong, the lights will go off at potentially, tens of thousands of households. So that's something that you do not want to do. So what we saw in the specification with regards to Shapeshifter is that we're a bit blind. Because we already read the document for a few years, you fill in the gaps. So what we're trying to do now, what we want to contribute is that in the documentation and the specification, that all the experiences that we have, that it will become an easier document for people to be able to use it. So we can communicate easily, somebody can easily implement it. And we're in the process of, from the Python code that we now develop, we are going to contribute at least parts of it to also the Shapeshifter library. So people that want to use Python already have some sense about, hey, this works, you can implement it like this, you can take this building block, because the last talk was around building blocks. We want to provide building blocks that people can use. So it's also easier to implement. And we're now inviting people also who did their own implementation, because they didn't want to use the Java implementation that is there, and the Python implementation that isn't there yet. And we want to have their feedback and ask them, hey, what do you see? What are you missing? How can we make the specification less that you need to interpret it and more clear? And also, we now, for capacity limit contracts, we use it in a certain way. Attributes need to be filled out in a certain way that you can use it for capacity limit contracts. But it's not really clear from the specification yet, because it's new. So we want to contribute our experiences into the specification so people can easily adopt it and get the building blocks that they need to build a solution and communicate with us. Robben?
Thank you for explaining how you use in your journey with Shapeshifter. So we're at the end of our presentation. If you want to know more, you can look us up on the LF Energy website, and also the specification is available on GitHub. If you want to know more, you can also talk to us today, or find us on LinkedIn or wherever. If you are thinking about using Shapeshifter or participating in the flexibility market and running into problems or challenges, please also let us know so we can, together with you, figure out how we can make this work and how we can make the protocol more available or more easy to use. That's it. Are there questions? Yeah, first in front.
Yeah, I was curious. So Shapeshifter is a specification, right? And right now it's implemented in Java and Python. That's correct?
Yeah. So the main body is the specification describing the messages, and we have a Java library available already in the project that you can use to implement it or facilitate your implementation. And Enexis is planning to contribute their Python library also to the project.
It's not only the documentation, it's also a set of XSDs. The messages are XML based, and with the XSDs, in combination with the documentation, you can build your whole messaging.
Yep.
Yes, I had a question about Shapeshifter. Do you mainly just talk about sharing what kind of capacity you might be able to shift and how quickly, rather than anything related to the compensation you might be requesting or offering? Maybe if you could talk a little bit about that, that'd be helpful.
So if I understand the question correct, it's about what are we communicating when we or when grid operators request flexibility, and what can flexibility providers offer. It differs. So there's a lot of things in a request. The grid operator can communicate the moments in time that there is a congestion problem and the volume of it, but can also communicate the available capacity on different moments in time. So if a party wants to shift for example, the charging of their battery to a different moment in time, it knows at what times there is capacity available. It can also respond with multiple offers to one request. For example, shifting charging of the battery to the morning for a certain price, and shifting it or charging it during the night for a different price. So the grid operator can then look at, okay, how does that fit into my in my grid at that time?
You can use it with fixed contracts that you already have with your customers, and let them know, I want to have this flexibility for this contract, for this, there's a specific target service type, that if a contract has multiple service types, and you can say, hey, I have this flex request for you regarding this contract. But as Robben told, in the offer message, you can have offer options. You can have that we send a request with where we have congestion and where we have availability, and somebody could, in their offer, tell us multiple offer options with their pricing. So then you as a DSO can see, all right, this one is interesting for me. I would like to go for this offer option, and there's a price in it communicated, and then you order it, and you have then sealed the deal. You get that flexibility regarding that price. So it's in the protocol, in the messaging, that you can specify prices or multiple offer options.
Thank you.
Welcome.
Yeah, there.
That's a bit sort of more business-related question, rather than the technical specs. What is your current experience with Shapeshifter? Is it something that's already operating in the market that DSOs are asking for and sort of happy about the deployment? Or is it more sort of we're laying the basis for this to work in the future? Because in my experience, sort of the DSO industry is very conservative for obvious reasons, because they have delivery engagements and they just have to deliver. What's your experience in the Netherlands?
I can do it. What we do now is we really have this implemented as the protocol for day-ahead communication. Our business really bets on capacity limit contracts, and Shapeshifter is the de facto standard for us regarding the communication protocol. So if we sign a contract with you, that requires that you do either one of two things. One is you have your own Shapeshifter implementation, so you can directly communicate with us. You need to keep track of all the contracts that have possibly also been already requested by the TSO, because we can talk to something that can also talk to the TSO. And the other option is that you decide that you use a platform like GOPACS, and then they abstract the protocol. The DSO talks to GOPACS using Shapeshifter, but GOPACS is then the abstraction in which you can just interface with the system, and you do not need to implement Shapeshifter then. But the DSO has implemented and chosen Shapeshifter, or at least Enexis, for using Shapeshifter as the communication protocol directly to the aggregators and the GOPACS platform.
So what you're saying is today this is operating and delivering actual congestion management that the DSO is asking for and using it.
Yeah.
Yep.
Impressive.
Thanks.
Question in the back? So the question is, how does capacity management with Shapeshifter interact with ancillary services like balancing actions that are requested by the TSO? That's a good question. That is also part of the larger framework Shapeshifter is part of. Yeah, so it also has to do with the timelines. So Shapeshifter is used day ahead or intraday. And the ancillary services are mainly used real time, but that is also always a trade-off where if you offer your flexibility to a grid operator like this, yeah, then you are limited in some ways in also doing balancing actions, because balancing actions like ramping up a battery can also cause congestion and can cause blackouts. So that is. Yeah, that is a trade-off that you can only sell your capacity once.
And what we do here, if you look at the day-ahead market, whenever you have a battery, and we would contract you, for instance, for capacity limit or for something else, then what we do is we ask that you send your measurements, so we know what you have done, but we also ask a prognosis, that you prognose what you're going to do. And in, for instance, the implementation that we do within Enexis with the grid management system, we combine all these data sources that we look at, okay, we need flexibility. Your connection contract matches one of those possible solutions. We see from your prognose that you prognosed this. If we ask you to limit below that prognose, that will give us a net result that will help us solving our congestion, and then we can communicate with you. And then after we say, all right, between 12 and 2, we would like your battery to unload or load for 2 megawatts, for instance, then we agree upon that. And after that, as Robben also explained, we have the settlement and the validation phase, where you're going to look at your prognose, your new prognose, your measurement data, and validate if you did what you saw, what you said that you did. So I think we have a red flag.
Yeah. So we'll address your question in the break afterwards, because we got a red flag in the back. So we need to stop.
Yep.
Thank you for your attention, and we looking forward to hearing your questions.
Yeah. Thank you.